Hi, question number 3. A cuboid has a total surface area of 150 centimeters square and it is such that its base is a square of side x centimeters. Show that the height h centimeters of the cuboid is given by h is equal to 75 minus x squared over 2x. Express the volume of the cuboid in terms of x. Hence determine as x varies its maximum volume and show that this volume is a maximum. Okay, so we need to show that the height of this cuboid is given by h is equal to 75 minus x squared over 2x. Now what I would like you to realize, we are given that the total surface area the surface area is 150 centimeters square. What do we mean by that? All these surfaces, we've got one at the bottom here, x times x is going to be x squared, then one on top here. Let me show you it here and here. So you got two like these, plus you got four sides, 1 2 3 4, and these are x times h, x times h, x times h, x times h. Okay, so I got 4x times h, and the total of that's going to give me 150 centimeters square. We need to find h, therefore h is going to be 150. You send the 2x squared on the other side, becomes minus, divided by 4x, and you can simplify further by dividing by 2, and you get 75 minus x squared over 2x, which has been shown. Now, this has been shown. Okay, good. Here's your answer. The second part, we need to express the volume of the cuboid in terms of x. And now what is the volume of a cuboid? The volume of a cuboid is going to be given by length multiplied by breadth multiplied by height. And the length and the breadth are x times x, which is x squared, times the height. The height's just been found to be 75 minus x squared, all divided by 2x. So, you cross out x, you minus 1 here. Okay, you're going to expand this. You're going to say x times 75 is 75x minus x to the cube, and you divide by 2. The whole expression is being divided by 2. So here we are. This is the volume of the cuboid expressed in terms of x. We need to find the maximum volume. When we talk about maximum volume, what are we basically saying? That over here dv by dx is going to be 0. That's the maximum volume. We're going to differentiate the volume. So if you differentiate this, you're going to get dv over dx is equal to half, alright, x, 75x to differentiate becomes 75, and 3x to the cube is going to become 3x squared. So this is your differentiation. We're going to equate that to 0 because we're looking at the maximum. Minimum and maximum is going to give you 0. So we're saying that 0 is equal to half times 75 minus 3x squared. And the half goes on the other side. It cancels out with 0. And you're left with 75 minus 3x squared is equal to 0. That means x squared is equal to, you send the 75 on the other side, or the 3x squared on the other side, and 75 on one side here, and you divide by 3, and therefore you're going to be ending up with x squared is equal to x is going to be root of 25. If you remove the square, it's going to become square root there, because 75 over 3 is 25, and then you remove the square, it becomes square root. So x is going to be equal to 5. Good. Now we need to show that this volume is a maximum. To find the nature of the volume, we're going to find the second derivative of this, dv by dx. So we're going to look for dv squared over d2x. Alright, and to do this, basically, oh sorry, make a mistake, d2v over dx squared. So we're going to redifferentiate this expression here. So if you differentiate, you're going to get half. The 75 becomes, if you differentiate 75, you get 0. You differentiate minus 3x to the square, you're going to get minus 6x to the power of 1. And that's going to give you minus 3x. And what was x? X was 5. So you substitute x in here, you're going to get d2v over dx squared is equal to minus 3 times 5, which is minus 15. So what were we looking at? This is minus 15, it is less than 0. When it is less than 0, the volume will be a maximum. Otherwise, if it was greater than 0, the volume would have been a minimum. And that has been shown as well. Here we are for this question, which is taken from revision 11 at Maths O level, and question number 3. Okay.